Hello everyone. In this video, I'm going to talk about how we represent species with covalent bonds. Basically, how we draw them so that it's obvious that we have a covalent bond. In my previous video, I showed you how as the internuclear distance for two atoms begins to get smaller and smaller and smaller, we have the most stable distance between them, and that internuclear distance becomes the bond length. Well, I could represent a covalent bond by drawing two nuclei and the electron clouds around it, but that would get to be really tedious for larger molecules. And there are other ways that I can draw it as well. I could show orbitals overlapping and so forth. Mathematically, these orbitals can be calculated for simple molecules, but we're not going to do that in this class, and the math is fairly complex. So instead, there are going to be a couple of simple ways that we're going to show a covalent bond. So the way that we will deal with shared electrons in overlapping orbitals is using a simplified graphic showing the orbitals overlapping. For example, in the hydrogen molecule below, and I'm going to draw a hydrogen molecule, I've got a hydrogen here and a hydrogen here, and I'm going to show their orbitals overlapping. So that's one graphic way to represent them. So you can see that this molecule, one hydrogen overlaps with the orbital of the other hydrogen. And this overlapping orbital space can then share a pair of electrons, right? That's a simplified way of drawing this without having to draw that electron cloud. But there's an even simpler way, and we're going to prefer the even simpler way. And that is to simplify drawing these structures Lewis dot structures. Or simply Lewis structures. Very often the dot is omitted when we're talking about a molecule. We use Lewis dot symbols for single atoms and Lewis structures for molecules. So you might see the word dot included. Some people do include it. But these are basically Lewis structures. And this should be a review to you. You should have seen this before in a previous chemistry class. Lewis structures are used to represent the structures of polyatomic ions. This is the structure, not the formula, of polyatomic ions and molecules. And remember the definition of a molecule? It is a neutral covalently bonded species. And remember that polyatomic ions are covalently bonded. All the atoms in that cluster are covalently bonded. So how do we represent the covalent bonds when we have these covalently bonded species? We're going to use Lewis structures. So these Lewis structures show the valence electrons, because bonding always happens with our valence electrons, our outermost or highest energy electrons, around each atom in the structure. So if we have a shared pair of electrons, a pair of electrons like this up here, where we are sharing a pair of them, that's shown as a straight line. And if there are any unshared electrons, that is, electrons that are on one atom but are not being shared by the other, they're represented as dots. So here are some examples, and we're going to do a full review of how to draw Lewis structures in a later video. It's going to come later in this workbook. But I just want to remind you what it looks like, and so I'm just going to include some examples of Lewis structures so you remember what they look like. And then a little bit later, a few pages from now, we'll cover how to generate a Lewis structure from the formula. So a hydrogen molecule. That's pretty simple, isn't it? It's a whole lot simpler than having to draw the circles and all of that. So notice that a shared pair of electrons is represented by the straight line. That right there is a covalent bond. It is a pair of electrons that are being attracted to both atoms, shared by both atoms, and we can draw it as a single line. So that single line represents 2 electrons. Water. We know the formula for water is H2O. This is the Lewis structure. This shows a shared pair of electrons here, a shared pair of electrons here, and then a pair of unshared electrons that the oxygen is not sharing with either of its neighbors there, and another pair of those here. Ethanol, this is the alcohol that is in alcoholic beverages. A little bit more elaborate. And you won't be drawing Lewis structures that are this elaborate in this class, but I want to show you that we can become more and more elaborate in our Lewis structures, and some Lewis structures could have dozens or even hundreds of atoms. So you can see once we start getting to larger molecules, it's really important that we have this simplified way of representing these electrons so that we're not drawing these circles and overlapping circles for every one of these atoms. Hydrogen, 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 hydrogen. So this is the formula for this, C2H6O, or the way that an organic chemist would probably prefer to see it written, CH3CH2OH. And if you take organic chemistry, which is the 200 level course, then you will see many of these sorts of structures. This formula for H2, this is the formula for water, and so forth. The ammonium cation. Now I mentioned that Lewis structures are also used to represent the structures of polyatomic ions because the atoms in a polyatomic ion are held together by covalent bonds. So we know that the formula for an ammonium cation is a nitrogen and 4 hydrogens with a positive charge on it. So the Lewis structure, this is the way that the ammonium cation is actually structured. And I put brackets all around it to show that the whole cluster has a positive charge. So nitrogen is bonded covalently to 4 hydrogens. So that's how we're going to represent our covalent bonds, by having these single lines, straight lines, to represent an electron pair that is being shared in a covalent bond. And any other valence electrons that are not being shared will be represented by dots.